My viewers, once again, I welcome you to my mathematics class. And today, we are going to treat number basis system. Over the years, we have been doing arithmetic in base 10 or ordinary. Arithmetic operations such as addition, subtraction, multiplication, and division can easily be done in base 10, beginning from the nursery to KG, to the primary, to secondary, and so on. Over the years, we have been doing arithmetic in base 10. Interestingly, we can carry out similar arithmetic operations in other bases than base 10 ordinary. In other words, those things we are used to doing in base 10, we can as well do in other bases. That is where we are going to now. But before then, let us do the following addition in base 10 as a way of refreshing our memory. We have to look at how we do it in base 10 before we can extend our ideas to other bases. So we want to add 529 and 675 in base 10. 9 plus 5, 14. You write 4 and carry 1. That 1 is added to 7 to get 8. Added to 2, you get 10. When you get 10, you write 0 and carry 1. That 1 is added to 6 to get 7. Added to 5 to get 12. You write 12. Finally. So that the addition gives you 1,204. Very often we do certain things without taking time to understand fully what we are doing. Now listening to this explanation, when you added 5 to 9, you got 14. 14. Why do you say that you write 4 and carry 1? One what? One what? You write 4 and carry 1. That one you are carrying is one bundle of 10. Why? Because you are operating in base 10. So the one you are carrying represents 10. You put down 4 and you carry 1. The one now you add to 7, you get 8, add to 2, you got 10. That 10 gives you one bundle of 10, remainder 0. Because that's exactly what you did in the case of 14. In the case of 14, it is one bundle of 10, remainder 4. That's why you put down 4. Here now, you are getting 10, which gives you one bundle of 10, remainder 0. You put down the 0. And carry that one bundle of 10. You add it to 6, get 7, add it to 5, and you get 12. The 12 means one bundle of 10 and 2. 1, 2. A bundle of 10 and 2. Now, we can transfer this idea to other bases. We can transfer this idea to other bases. Notice the transfer of bundles of 10 I have explained that using base 10, which we are all familiar with. Now let us add the following. Let us try and imitate what we did in base 10. Let us try and imitate it in other bases. We are to add 6 4 3 7 2 3 4 2 5. This time in base 8. This time we are doing the addition in base 8. Let us follow what we are doing gradually. 5 plus 2 is 7. Plus 3 is 10. But you are operating in base 8. You are operating in base 8. So the 10 you obtained now doesn't arise. In base 8, that 10 represents one bundle of 8, remainder 2. So you put down the 2 and carry one bundle of 8. Add it to 2, you get 3, plus 7, you get 10, plus 4, 14. 14 is not one bundle of 10 and 4. No, because you are no longer in base 10. So that 14 now in base 8 is one bundle of 8, remainder 6. You put down the 6 and carry 1. The one you are carrying represents 8. 1 plus 4, 5, plus 6, 11. 11 in base 8 is one bundle of 8, remainder 3. You put down the 3 and carry one bundle of 8. Add that one to 3, you get 4. And you have completed the addition. This time in base 8. You can see that we are trying to imitate exactly what we did in base 10. Now go over to base 6. These numbers are to be added in base 6. 1 plus 0, 1 plus 4, 5. You put down 5 because it is not yet up to 6, up to one bundle of 6. 5 is not yet up to one bundle of 6. So you put down the 5. 1 plus 1, 2, plus 2, 4. Not yet up to one bundle of 6. You put down the 4. 2 plus 2, 4, plus 3, 7. 7 is one bundle of 6, remainder 1. One bundle of 6, remainder 1. So you put that 1 down and carry one bundle of 6. 1 plus 3, 4, plus 3, 7, plus 5, 12. Now, this 12 gives you two bundles of 6, remainder 0. So you put down 0 and carry 2 bundles of 6. That 2 now is added to 4 and you get 6. Now this 6 is one bundle of 6 and 0. One bundle of 6, remainder 0. 1 0. 1 0. 1 0 represents 6 in base 6. One bundle of 6, remainder 0. So that's it. That's what we get in the addition in base 6. In base 4, look at this. 3 plus 1, 4, plus 1, 5. 5 in base 4 is one bundle of 4, remainder 1. So you put the 1 down and carry one bundle of 4. That 1 plus 3 is 4, plus 1, 5, plus 1, 6. In base 4, 6 is one bundle of 4, remainder 2. So you put that 2 down and carry the one bundle. 1 plus 3, 4, plus 2, 6, plus 3, 9. 9 in base 4 is 2 bundles of 4, remainder 1. 2 bundles of 4, remainder 1. Are we right? Sorry. We carried 1 from here. To put that 1 here, we have 4. Sorry. Add 4. 1 here. This 1 here is 4. Plus 2. 6 plus 3. 9. Let me check, please. There appears to be error in this one. Now let us go through this over again. 3 plus 1 is 4, and 4 plus 1 is 5. And in base 4, it is 1 bundle of 4, remainder 1. You put down the 1 and carry 1. 1 plus 3 is 4, plus 1, 5, plus 1, 6. 6 in base 4 is 1 bundle of 4, remainder 2. So you put down the 2 and carry 1. 1 plus 3 is 4. 4 plus 2 is 6. And 6 plus 3 is 9. 9 contains 4 bundles of 2 bundles of 4, remainder 1. 2 bundles of 4, remainder 1. So you have to put 1 down there and carry the 2. 2 plus 1 is 3, plus 0 still 3, plus 2, 5. And 5 of course. 5 in base 4 is 1 bundle of 4, remainder 1. So you put that remainder on here and carry 1. 1 plus 2 is 3, plus 1, 4. 4 in base 4 is 1 bundle of 4, remainder 0. We have to put down that 0 here and carry 1. 1 plus 3 is 4. Another 1 bundle, remainder 0. So that is what you have there. Now, when you come to base 2 or binary, you have these 2 numbers to be added. 1 plus 1 is 2, and we are working in base 2. So that gives you 1 bundle of 2, remainder 0. You put down the 0 and carry 1. Add the 1 to this one, you get 2. To this one, you get 3. 3 in base 2 will give you 1 bundle of 2, remainder 1. So you put down the 1 and carry the 1. 1 here is 2, 3. 3 in base 2 again is 1, remainder 1. So you put down the 1 and carry 1. 1 plus 1, 2, plus 0 still remains 2. 2 in base 2 is 1 bundle of 2, remainder 0. So you put down the 0 and carry 1. 1 plus 1, 2, plus 1, 3. 3 in base 2 is 1 bundle of 2, remainder 1. You put down the 1 and carry 1. 1 plus 1 here will give you 2, which is 1 bundle of 2, remainder 0, 1, 0. So you can see how interesting it is for us to do arithmetic in other bases than base 10. I want us to observe very clearly that in every base, including base 10, in every base, you don't have any number in any base does not contain a digit that is equal to or greater than that base. What do I mean by that? Operating in base 10, you can see that all the figures 5 through 9, 6, 7, 5, the highest you can get is 9. You cannot get 10 in base 10. You cannot get 10 in base 10. The highest you can get there is 9. You can get from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits you can get in any number in base 10. Similarly, when you go to base 8, you cannot get any number containing any digit that is equal to 8 or more than 8. You cannot get 8 in any figure in base 8. You cannot get 9 in any figure in base 8. But you can get 0, 1, 2, 3, 4, 5, 6, 7. You go to base 6. Any number in base 6 cannot contain any digit that is equal to 6 or above 6. In base 6, you can get 0, 1, 2, 3, 4, 5. You cannot get 6, cannot get 7, cannot get 8, cannot get 9. And so on and so forth. Look at the numbers in base 4. You cannot get 4. The highest you can get there is 3. Then look at numbers in base 2. The digits you can get in any number in base 2 is 0, 1, 0, 1, 0, 1. You cannot get 2. You cannot get 3. You cannot get 4. You cannot get 5, and so on and so forth. So take note of that. That any base you are operating on, no number in that base can contain any digit that is equal to the base or greater than the base. Thank you very much for the amount of work we can do today. In our next lesson, we shall still continue with other arithmetic operations on different number bases. Thank you and God bless.